Okay, let's start a class. Again, we have a lecture in here, 1 to 150. We have 30 students. We're going to use all the computers. And okay, so today I'm going to talk about HEC-RAS, basically to do a demonstration. So as just mentioned, so the first one, to start a software, and if you go to the start button and find out civil engineering, then you can find out HEC softwares, and then the HEC-RAS, then HEC-RAS 4.1, okay? If you launch the software successfully, and this is the window you're going to see, okay? And as I mentioned that, we're going to have a computer exam for this software. And I mentioned that it's not purely 100% like a closed book, because if you go to the help menu, you're going to see user's manual, hydraulic reference manual, and application guide. So let's start, click on the user's menu, okay? Because this is the PDF file I got. So if you go to this is chapter 4, okay, example application, okay, this is the chapter which we are going to go through step by step. And I mean, we're going to do the demonstration today and Wednesday after that. And I would like you to really read the detail and also the chapter 3, okay? And you're going to have about 2 or 3 computer projects using HEC-RAS, so you can get some practice for that also, okay? So in this class, we're going to talk about studying a new project, entering the geometry data, and enter the steady flow data, and perform the hydraulic calculation, and view the results, and print the graphics, the tables, and so basically for the computer part exam, you're not going to print out anything, but for the computer projects, you need to print out the graphs, the tables as a part of the project, okay? And for the exam, most likely you'll start from an incomplete project, which I'll save on the network drive, okay? So, but now we'll start from scratch, okay? So this is the interface. So you can see these pull-down menus and these toolbars. So this is just like the typical open the project, or you can just go to File and have these different options. So we access the file. So you can see the new project and open the project. So like in the computer exam, most likely you open the project. So let's go to new project. I think we need to select a network driver to save your file. And because I think if you save in the local computer after you close, they'll wipe out those data. So try to save in your L drive, your network drive, and the graduate students select save in your G drive, or you want to save in a USB port, because we may not be finished the demonstration today, so we'll continue on Wednesday. Okay, so don't save on the C. And so for me, I'm going to save in my H drive, okay? I just select a folder in here. Let me see, select a different folder. Let me start, okay. I select H driver, okay? As I mentioned, the undergraduate student try to select your L driver, okay? And the graduate student, you can select the G or other network drive. So I select my H drive. So let me create a folder in here. And I just say the chapter 4 in here. Okay, so you have to select the particular drive and the folder. So then you can enter the title Okay, that's basically the title. And actually, I may need to do something different because I have this folder already for the past practice. So let me create a different one. And so start from scratch. Example 1. See, where do I have? Okay. Okay, so you can enter a title to describe the list project, okay? And so basically, you can type example 1 for steady flow simulation. But that's, okay, and example 1 for steady flow simulation, then they have the file name, and you can make them short. They make it pretty long. So the example 1, and for steady state, I can just delete some extra characters. So my file name for the project is just example1.prj. That's the highest level as a project, so it's always as extension.prj, okay? Then I'll select OK. Okay, they'll pump a window for you. Start a new project with example1.prj as is a file name, and example1 for steady flow simulation as is a title. And in this H driver, chapter 4, example 1, whatever the directory you select, okay? And also the next thing you need to pay attention, the unit system will be set as a US customer unit, but it can be changed on the option menu on the main HEC-RAS window, okay? For us, it's okay because we're going to use the engineer system, US customer units, okay? And otherwise, you need to go to change to the SI units, okay? So we just select OK. So right now, under the interface, you can see the project. We already have the project title and basically the location where the file is saved and the file name, okay? So you can see others like plane, geometry, steady flow, unsteady flow, these are still blank. So basically, after we import other data, and we'll have other information, okay? So as I mentioned that, so we create a project, and the next thing is the geometry data. That's the one you have to go through for all the projects. Just like in the spreadsheet project, you have to tell the spreadsheet you are doing a triangle channel, trapezoid channel, like bottom width, and so on, okay? So we're going to enter the geometry data. So basically, if you click on the menu, Edit, so you have the option. The first thing is the geometry data, okay? And the second is the steady flow and the quasi-unsteady flow, and so on. Okay, we are going to use the geometry data and the steady flow data for our basic application. Or you can click on a button, the third one, because the first one is open, the second one is default, like a disk is a save. If you put there, you can see the tip. The third one, the button is Edit and Enter Geometry Data. So you can click on that button also. So you pump another window, okay? And so basically, let's start to enter geometry data. As we mentioned in the class, the first thing is enter the river ridge. Okay, so if you see this button, add a new river ridge to the schematic. So again, this is a schematic. So if you click on this, if right now move into the screen, it's just an arrow. Okay, if you click on river ridge, now become a pencil. Okay, so if that is selected, the first one, river ridge. Okay, and for our study, for this particular example, and I showed you before, we're going to enter a river ridge shows in this way. So basically, we have two rivers. One is a Fall River, but the Fall River will be entered as 2 ridges, upper ridge, lower ridge, and there's a tributary. And I also mentioned that actually the simplest project could be just click on 2 points, 1 point and then another point, and just as a straight line. That's just 1 ridge for your project. That could be the simplest river ridge. Okay, so for us, we're going to enter that Y shape of the ridge. Okay, so if you look at some information dealing with enter the ridge, we always will start from upstream to downstream. Okay, so you see right now the flow direction is start from here. Okay, if the flow direction actually is from south to north, you start click on here and end over there. So you have to enter the points in the direction and same as the flow direction. Okay, and since it's schematic, so it is not that crucial and how many points you want to enter. If you do a real project, actually you can load a background for your study area first. Then you can trace the real river. Okay, in this case, we can just start in here. Okay, where's my cursor? Okay, so just start from here. So if you click on your mouse 1 point, so you can click another point. So you can click on several points. Try to sketch this branch. And as I mentioned, it is not important how do you click on this point because it's just schematic diagram. So at the last point, what you want to do is double click. So if you double click on that, so you'll see a small window, okay? Selecting existing river or enter a new river. The name is 16 characters maximum, and rich name 16 characters maximum. So for this example, so what we have is a Fall River, okay, and then the first ridge we put is up ridge, okay. So enter the river name as a Fall River and the ridge as upper ridge. Okay, then you select OK. Then you can see the name of the river and upper ridge and also flow directions are shown. As I just mentioned exactly, we start from here to here. So that's the flow direction as a default. Okay, so let's enter the lower ridge. So basically, upper ridge and the lower ridge is divided for the simulation purpose. Supposed to be start from here and go continue. So basically, so the next one is click on the river ridge again and try to locate it close to the end point. Okay, and then start the first point and the second point or number few points. At the end, double click on that. Okay. And so right now, and you already have Fall River, but the ridge, and somehow for me, maybe select too close, they just take a default name. But this is a lower ridge, so we have to enter the lower ridge for the ridge name. So the river is still Fall River, okay? So we have Fall River, lower ridge as the ridge name, okay? Because I start this point and so close, and they automatically ask me, because I use the same river name. So these two different ridges, you have to connect them by a junction. So basically they say enter a junction name, connect the ridge, lower ridge and upper ridge for that, okay? Okay, if you look at diagram, I think we call the Sutter, okay, S-U-T-T-E-R. Okay, that's the name for the junction. Okay, Sutter, okay, S-U-T-T-E-R. And they show this message, the extent of data are beyond the current schematic. So some of the picture river ridge may not be available. Do you want to increase schematic extent? You say yes, okay. So right now you see there's a red dot added there, okay, shows the name of the junction. So connect four ridge, up ridge and lower ridge, okay. So now let's add the tributary. So you can click on the river ridge again and start from somewhere in here. Click on few data points, and at the end, just close to the junction, double click on that. So now is a different river. So what we name is as a tributary. So the tributary will be the name of the river, and the ridge name will be the Butter Creek. If you open the PDF file, you can see that, okay, the name of the river will be Tributary and the ridge will be the Butter Creek. And they just, yes, okay. So now you have the schematic of the river network, which we are going to set up for the HEC-RAS. So the next thing you can quickly check is under the, I think it's on the view. Okay, let me see. Option. Okay, edit. Okay, actually it's under the edit menu. You have the one change the name, okay, such as up ridge or lower ridge. If you want to change the ridge name or river name, you can do that. Another one is move the object, okay. So now you can see all the data points you collected before are given in here, and also like the name is an object, so you can move and don't want to make them overlap, okay, such as this name for the junction, okay, or such as this point you want to make as a different shape. You can click on any point, okay, but those are not crucial, okay, because this is a schematic, okay. As long as you set as this Y-shaped river network will be fine, okay. Edit, move object, okay. Okay, before continue, so let's go to the file and save the geometry data, okay. Let me see what it did. So this title they call the base geometry. Base geometry data. Or sometimes you have the existing geometry, and because we may make some modifications. Okay, so the title is base geometry data, and the file name you don't need to enter because it's a default. Pick up the file name for the project and add the extension .g, and then there's a G1, G2, G3. So you have the geometry data file for 1, 2, 3 different versions. Okay, so you just need to enter some information for the title, then say OK. Okay, so if you close this window, if you go back to the main window, now you can see the geometry. We have the title for the geometry data file and the file name and the location. Okay, let's go back to the geometry data again. So we have the river network. So the next thing which we have to do is enter the cross-sectional data. So if you look at the right panel, so you can see the junction, which is, if you look at the tip, added existing junction and cross-section, and the bridge covers, and inline structure, lateral structure, and so on. So for us, we are going to click on the cross-section. Okay. They show me this one. So let's just click on cancel, see what happens. Okay. So after you click on the cross-section, and you'll see this new window. Okay. And basically, so right now, because we have not entered any data, so the first thing which you have to do is which river and which ridge you want to enter data. So you can see the list of river. So if you click on this one, you see we have the option for the Fall River or Tributary. So let's select the Fall River. And the ridge, if you select that, we have two options, up ridge and the lower ridge we entered before. So let's select the Fall River and the up ridge, okay? And then you can go to the options, okay? Because if you don't select the river and the ridge first, you go to the option and you may enter the cross-section data in a wrong river and the wrong ridge, okay? So now you have to go to the options button. So the first one available to you is add a new cross-section. So let's click on that. So now they pump a small window and a new river station for the new cross-section in the ridge up ridge. Okay, so now we are going to enter the river name as a 10. Okay, as we mentioned before last week, so the HEC-RAS use a system to name the cross-section as like a real number. Okay, the cross-section with the highest number is default as upstream. It's a real number, so you can do 10.1, 10.2, or and so on. So, but right now, and this is cross-section 10. Okay, so now after you say OK, so you can see the river station 10 has been saved in here already. So you have the description. So description is you can put some text because we are not able to put any like text for the naming the station. So in here you can enter that. So you help yourself or future user. So we can type like a upstream boundary of the Fall River. So we know this is the most upstream cross-section. Okay, so that's the description. Okay, so again, that's just information. Okay, if you don't do that, and the program will still run. Okay. Okay, so as we mentioned before, for the cross-section geometry, we have to enter paired data as given in here as like a station and elevation. Okay, and basically, if you look at the so just like this is the cross-section we are going to enter. So the x-axis is a station from a certain reference point, then the elevation. So we have the station for 1, elevation 1, station 2, elevation 2 to outline this cross-section. And okay, so data which is given in here, okay? So let me type the data and follow me. So basically the first one, the station is 110. And I think you put the enter, they move automatically to station. So station will be 90. And the next one, station is 120, elevation is 80. Then the next one is a 200 as a station, elevation as a 78. The next one, the station 210, elevation as a 70. And the next one, station 230, elevation as a 71. And the next one, station 240, station 79. And the next one, station 350, elevation as 81. The last one, station 360, elevation as 91. So we have 8 pairs of data of the station and elevations to outline. Okay, the next thing you have to do always is the downstream ridge length. We talked about that before, is from the current cross-section to the next cross-section, what is the distance? So we have to enter 3 lengths. One is LOB, as we mentioned, that's a default terminology. LOB is the leftover bank area. The distance is 450, okay? And the next one is channel. That's the distance along the main channel is 500. Then the ROB is for right over bank area is 550. As we mentioned that, these 3 numbers may not be the same because river is meandering, so the length could be different. If somehow that the same, it means that that part of ridge is kind of straight. Okay, so the distance all the same. The next thing is Manning's value. We also need to enter 3 Manning's value. One for left overbank area, 0.06, and for the channel, and 0.035, and for the right overbank area, 0.05. And based on our discussion, so you need to understand the Manning's M values in the overbank areas should be always larger than the M value in the main channel. Okay, but like in the left, right overbank areas could be different. Like in this case, 0.06, 0.05, that's fine. But you see, both are greater than the M value in the main channel. Okay, because you have the water flow in the main channel most of the time. But the overbank area, only during the flood season, you have the water flow. Other dry period, you may have the growing of the vegetation. Sometimes you may have some temporary structure over there. That's the reason we have large M value in the LOB and the ROB. The next thing is the main channel bank station. Basically, what we're talking about before is like we have to tell the computer, okay, which part is the main channel. Basically, and these 2 red dots, basically is 2 pairs data. And so we know that on the left of the first red dot, that's the left overbank area. On the right of this red dot is the right overbank area. Between them is the main channel. Basically, what we need to enter is only the station, okay? Main channel bank station. And what we need to do is 200 and then 400. Excuse me, 240. These 2 numbers has to be on the list of the station you already entered. So such as we already entered 200 in here, 240, okay? You cannot just type a number, let me enter like 190, okay? Which is not on the list or 250. So these 2 station numbers have to be on this list of the station you already entered, okay? The next thing is the contraction and expansion coefficient. And that's basically local head loss coefficient. They already entered for you, 0.1 and 0.3. That's the default value. As we mentioned that until we have the flow simulation passing through the bridges or covers or some sudden contraction, then you can change it to such as 0.3 or 0.5. Otherwise, we just accept the default value, 0.1 smaller for contraction, 0.3 for expansion. Okay, so now we have entered all the data. So you can go up, click on this applying the data. It means accept the data we entered. So now you can see the graph show the window, show the channel. Okay, if somehow you made a mistake in here, the channel geometry could be odd, then you can go back to make change and apply again. So you see right now you have lots of information. You see the x-axis shows a station in feet because we used US Customs units, and the y-axis is elevation in feet. So you showed we have 8 data pairs, 8 points to outline the channel geometry. They also shows 2 red dots. This is the left, right bank station for the main channel, and top they also already aligned for you. So this is the Manning's M value and aligned exactly up to the this bank station. Okay, and then between these 2 bank stations, you have the 0.035 as the Manning's M value, then 0.05 for the Manning's M for right overbank area. They also show you like example 1 for steady flow simulation. That's basically the project title you entered before. They also show you upstream boundary of Fall River. That's the description for this project, okay? And so they have lots of information already entered for you. Okay, so we successfully entered the first station. So now we are going to enter the next station, okay? So what we're going to do is go to the option, okay? So after you enter the first cross-section, now you have more options. You can select add a new cross-section. Then you start from scratch to enter the data as we just discussed. But right now we want to use the second method, which is copy the current cross-section data and make some changes. Okay, so let's click on copy the current cross-section. Okay, so now you have this window. So you can select the river, ridge, and river station. So we're not going to change the name for the river and ridge, but we are enter the data for a new cross-section. So the river station will be entered as 9.9, which is less than 10. The HEC-RAS knows that. That's a station downstream of the cross-section 10. Okay, so enter the number 9.9. Okay. So actually, the 9.9 is already showing this way. So how can we make some changes? So if you click on the option menu, so the second part is adjust elevations. Okay. So like in the spreadsheet project, you can enter the slope, but in the HEC-RAS, you have to enter the elevation. So even though I know it's a constant slope, okay, and I have to enter the elevation change. So for this one, what we are going to do is, if you look at the statement, enter mount to add to the elevation is plus minus. So I put a minus 0.5. It means that elevation for the station 9.9, all the elevation is 0.5 feet lower. Okay, for the cross-section 10. So if you click on OK, okay, before I click on OK, you look at those elevations, still the original one we entered, 90, 80, 78. So after click on OK, so you can see the number automatically change from 90 to 89.5 and 80 to 79.5. So we're applying that change. Now we also have to do some more. If you go to the options menu again, the next one is adjust station. If you click on adjust the station, there's two options. And the one is multiply by a factor or add a constant. If you add a constant, essentially you just shift the channel. Okay? And most time we use multiply by a factor. Multiply by factor is talk about a downstream cross-section could be narrow or could be wider than the previous cross-section. Okay, basically the left-right overbank area will be about 10% narrow. Okay, what we are going to do is we are able to enter three numbers. For LOB, we'll enter 0.9. Okay. For the ROB, we'll enter 0.9. So tells the HEC-RAS we have left overbank area, right overbank area are 10% narrow. Not 0.1, we have to do 0.9, 10% narrow. But for channel, I'll leave as a blank. Okay, if you don't put any number, they'll not change anything. Okay, if you type 1, that's fine too. Okay. So just leave as a blank for the channel and click on OK. Okay, so you can see these numbers also change because originally is 100 and 120, but now become 119. And also you see for the main channel station, originally we had 120, 240, 240 I think, right? Yeah, they also shifted, okay? So these numbers are also updated for you. So right now, what you have to do is apply data, accept all these changes you just did. So now we have the data for the cross-section 9.9. Okay, we are going to do the same for the next cross-section in similar way. So we go to the option and copy the current cross-section, which is 9.9, okay? And if you somehow you flip it back, check 10, whatever, so make sure before you do the copy and see which one is the current cross-section. So this is copy the current cross-section. So we enter the station as 9.8. Okay, we go to the options, adjust elevation. In this one, the elevation will be minus 0.4 feet lower. Okay, and then adjust the station. We do again multiply by a factor. We use the point A and the point A for left and the right overbank area. Okay, no change on the channel. Then click on OK. Okay, let me just double check one thing, whether I missed one thing or not. Yep. Okay, I did not change the channel length for 9.9, but there's no changes. Okay, but for the 9.8, we have to do some change. So the downstream reach length for the LOB for main channel all will be 0. What does that mean, 0? It means that the cross-section 9.8 is the last cross-section of this up-ridge. So in up-ridge, we only have 3 cross-sections, 10, 9.9, 9.8. There's no other cross-section further downstream 9.8. So this distance is 0, 0, 0, which is Tails computer. This is the last one. Okay? Then you are applying the data. Now we are going to enter the cross-section for lower ridge. So you can do the same. Go to the options, copy the current cross-section. But now I have to change the ridge name to a lower ridge. And the river station are going to put a 9.79, which is still smaller than 9.8. So it's further downstream. First of all, no change on the river name, change the ridge to the lower ridge. Then you can enter number 9.79. Click on OK. Okay, and so I think we need to remove this description, and which is called upper ridge. Okay, we may need to go back, change others. Okay, okay, do the same. Adjust the elevation, and going to be minus 0.1, slightly 0.1 feet lower, and adjust the stations, multiply by a factor. So in this case, we are 1.2 and 1.2 for the main channel and 1.2 for the right overbank area. So it means that the upper ridge and the tributary meet together, and the downstream is become a little bit wider, 20% wider. So it's 1.2. Click on OK. And now we need to go back, change this distance 0 to 500. Okay, for all. So 500 for LOB, 500 for the channel, 500 for the right overbank area. There's no changes on Manny's end, and the bank station was automatically updated by the software. Then you can select OK, apply the data. Then copy current cross-section again. So make sure it's still Fall River, Lower Ridge. So this one will be 9.7. Okay, and go to the option, adjust elevation, and will be minus 0.5 feet lower elevation. Go to the options and adjust the station, multiply by the factor. We'll enter the 1.2 again for all 3 parts, 1.2 for LOB, channel, ROB. Then OK. Distance is still 500. Then apply the data. So go to the copy the current one. So we enter the cross-section 9.6 for the lower ridge. And just elevation, as a minus 0.3, but there's no adjustment for the station. So, and the distance is still 500 for all. So then just apply the data, okay? Then the last one, copy the current cross-section. We enter the cross-section 9.5 and go to the option, adjust elevation as a minus 0.2. And no change on adjust stations. Since this is the last cross-section, so we have to set the length to be 0 for all three again. So the downstream reach length for all three paths will be set as a 0 again. Then you can apply the data. So right now, if you click on this river station, so for the lower ridge, we have the station 9.79, 9.7, 9.6, 9.5. If I select the up ridge, okay, so we have a cross-section 10. If you click on 9.9, because and actually I did not ask you erase this description, and so let's erase this description upstream of boundary for Fall River, because 9.9 is not that case. So you can raise that description, apply the data again. 9.8, I also erase that description upstream boundary of Fall River and apply the data, because we only have one upstream boundary. That's only for 10, okay? So now we have 7 cross-sections for the Fall River, 3 for up ridge and 4 for lower ridge. So now we need to do for tributary. So let's select the river as a tributary. Then we don't have any cross-section. There's only one ridge, Butter Creek. So only thing you can do is go to the options and add a new cross-section, okay? And this cross-section will be named as a 0.2. Okay, so we are going to end this information. So, and or you can type the information. This is the upstream boundary of the Butter Creek. Okay. Okay, for the station. So the first one is 210. The elevation is 90. The next one 220. Station 82. Excuse me, elevation 82. Station 260. Elevation 80. Station 265. Elevation 70. And the station 270. Elevation 71. Station 275. Elevation 81. Station 300, elevation 83. Last one, station 310, elevation 91. Then we put the length for LOB 500, for the channel 500, for ROB 500, for the maintenance end left over bank area 0.07, main channel 0.04. For the right over bank area is also 0.07. For the bank station left one is 260, and the right one is 275. Okay, except the default contraction expansion. So it means that for this main channel is about 15 feet wide, from 260 to 275. Okay. So let's apply the data. Okay. Now we do the same. Go to the options, copy the current cross-section, and enter the cross-section 0.1. So we can go to the option, adjust elevation, and will be minus 0.6 feet lower for the elevation. Then we go to, there's no changes to adjust the station. the length are still the same, then we can just apply the data. Okay, and the last one, copy the current cross-section. The station is a 0.0. That's fine. It's a real number. Even you can put a minus. Okay, 0.0. And go to the options, adjust the elevation as minus 0.3 feet lower, and no adjustment for the station. But since this is the last cross-section in the tributary, so the length will be set as 0 for the LOB, for the ROB, for main channel. And then apply. Okay, so now you can basically the exit cross-sectional data edit. Okay, so in this point, make sure go to the file and saved geometry data, because we already entered about the 10 different cross-section data. Okay, you see right now, originally we only have like a Y-shaped network, but right now you see about 10 different brown lines. So these are indicate the cross-sections we entered. You can see the cross-section 10, 9.9, 9.8, and 9.7, 9.6, 9.5, 0.1, 0.2, 0.1, and these three cross-sections are overlapped together. So we need to do something. Okay. So the next thing is enter the junction data. So if we click on the junction, okay, and they pump the junction data, enter. So we only have one junction. We cannot do anything. Okay, and for the description, they say this is a flow confluence of the Fall and Butter Creek. Okay, flow confluence of the Fall River and the Butter Creek. Okay, the thing which we need to enter is look at this part. Okay, the length across the junction. Okay, is from what? From the Fall River lower ridge to the Fall River upper ridge. Okay, and the list number will be entered as 50. And the next one is 60. So basically, and we have the cross-section at the lower ridge as 9.79. Use that as a reference. So what is the difference from this cross-section to the lowest cross-section in the upper ridge, which is 9.8? That distance is 50. And then cross the junction to the lowest one in the tributary is 60. Okay? Don't mix these two numbers. Look at the description. It's from what to what? From Fall River lower ridge to Fall River upper ridge, that's 50. From Fall River lower ridge to tributary Butter Creek is 60. Okay? And they also have some other methods you want to use, such as for the junction, do we use the energy equation to do the calculation or momentum equation? Right now we select the default one, energy. If you select the momentum, you may need to enter the angles. If you remember when we described, you need to enter the angle, so these two flow meet together, and how to exchange that. Okay? So just click on OK. So after you click on OK, so you can see for the junction, these three cross-sections are separated by that distance. From 9.79, okay? So let me just go to the edit, move the object again, this move to the side a little bit, okay? So now you can see 9.79, 9.80 is kind of like overlapped. See whether I can change it. Okay, I think that's fine. It's just slightly overlap. I was trying to move that number. I cannot move that number, I think. No, I can't. I can move this, the name of the junction. Okay, let's go to the file and save the geometry data one more time. Then you can close this window. Okay. So we're out of time, so we'll continue next time. So before you close that, so go to the file and save the project. Okay. Then we'll start from this point on Wednesday. We'll enter the steady flow data, run the model, and show you how to view the results. Okay. I just graded the second computer project back. Okay. If you did not get it, look around. Okay. Okay. We'll stop here for today. Thank you.